Box plot, a quick and easy way to look at a distribution. We're going to use the same data set that we used for the stem and leaf plot. Look at a distribution by grouping numbers from high to low based on the first digit. Suppose we have the number set. The first thing we do is to order these numerically from high to low. Since we're using the same data set from the stem and leaf, we know that the median is 20. We can determine the average is 20.5. The next thing to do is divide the group into percentiles. We know the 50th percentile, represented by Q2, is the median. 31 numbers plus 1 divided by 2 equals the 16th value. 25th percentile, represented by Q1, is 16 divided by 2, which gives us the 8th value from the low end. The 75th percentile, represented by Q3, is 16 divided by 2 is the 8th value from the high end. We then use these numbers to begin our plot. Here are the numbers represented, showing you Q1, Q3, and Q2. We start making our box plot with a set of Cartesian coordinates. This one is set up with a 0 and a maximum of 40, as our largest value was 37. The 75th percentile, Q3 value we have is 23. We place a line across at 23. The 25th percentile, Q1 value we have is 15. We place a line across at 15. Next, we calculate the IRQ, which is the difference between Q3 and Q1. 25 minus 15 equals 8. The IRQ value is then multiplied by 1.5, which along with the other values will give us a good estimate of a normal curve. 1.5 times 8 is 12. The upper whisker boundary is Q3 plus 1.5 IRQ. 23 plus 12 equals 35. We place a dashed line across at 35. The lower whisker boundary is Q1 minus 1.5 IRQ. 15 minus 12 equals 3. We place a dashed line across at 3. Now we go back to our data set. The largest value that we have that is less than 35, the upper whisker boundary, is 33, so we place a small line at 33. The same way, the smallest value that we have that is greater than 3, lower whisker boundary, is 6, so we place a small line at 6. We also have a value that is outside of the upper whisker boundary. This is called an outlier. We place a dot on any of these values. The same would hold true for any value less than the lower whisker value. I have seen use of extreme outliers. These would be any value that is outside of the values of Q3 plus 2 times 1.5 IRQ or Q1 minus 2 times 1.5 IRQ. Once we have these values plotted, we can then finish the plot. We draw straight vertical lines close to the box. Then we draw the whiskers as dashed lines. In the example we are using here, we are actually plotting values for the length of the whiskers. This gives us a more meaningful estimation of our data set. We can then plot both median and mean. The next thing to do is to understand how all of this fits together. We have a representation of a box plot over a normal curve. How the box plot represents the majority of the normal curve and therefore the values that are within 50% of the mean. The whiskers then include everything that represents 99.3% of all values of the normal curve. This allows us to make an estimation of normality when looking at these curves. Box plots can give us important information about the data set that we are using and allow us to visually compare the data set to give us a good estimate of the distribution of the data.